Hello, everybody. I'm Matthew Blackmore from Dyson. I look after the packaging here with a great team of packaging engineers and designers um, based in the UK and across in Southeast Asia in Malaysia. Um, we tackle we tackle all the products that Dyson produce, which a lot of you probably have at home and very familiar with. But today I'm going to tell you through a story about lean engineering. Engineering is one of our kind of core principles. It's really uh, something that our founder James is wholly passionate about, and that comes through his work and his guidance, but also through our values, and you can see those on screen there. We do things differently. We're famous for it. We often do things that don't work, that you never see. But whatever we do is done for one purpose of solving problems that other people ignore. And that kind of attitude and approach to things we consider to be very pioneering. If it's not tough enough, then it's probably not the right solution. And that's kind of our everyday culture. Is what we sort of live and breathe here. It's a very different culture from many that I've been used to and many will have experienced. But sometimes that approach is probably the most creative. So today, I'm going to just focus on one product, and I just captured this visual that just shows the range of products that we've done over the years. You can see the technology, how that's evolved through various vacuum cleaners, where we started nearly 30 years ago, all the way through to air purifiers, and latterly moving into a brand new category for us, which was hair care, where again we've pioneered new technology, reimagined the hairdryer, and subsequent products that are really transforming that beauty industry. But today, I want to focus on two items there that I've highlighted, which is our robot vacuum cleaner. And for many years, this has been our kind of crown jewel, if you like. It's got a significant price point, but it's also got a significant amount of technology in it. And primarily, it's been focusing on essentially what you can see in the center there, which is our 360-degree eye. This lens there is very fragile. It's very clever as well. And what this eye does, it really provides all the technology within that machine, enough data and information to be able to work with you as a consumer, and adapt to your lifestyle, adapt to your living environment, to help clean it and just take away some of that those chores that eat up our valuable time these days. The eye is a really good image, I think, to land on, because for us, it's not just looking at problems that we can solve, but it's actually looking at ourselves as well. And over the past sort of 6 years or so, we've looked hard at technology, but also looked hard at our packaging too. And I think the world is a very different place from it when this product was launched. And so the packaging has also evolved as well, moving much more towards sustainable agenda for us, and but at the same time using our engineering principles to work with materials that we prefer to work with and get rid of those that we don't. The robot itself, it maps its way around. It learns as it goes, and very much so. Our product was doing the same thing since the first launch about 5 years ago. The latest evolution of that is the one I'm going to focus on today, which is the 360-degree Heurist. As you can see, the lens on the robot has become much more advanced. There's much more technology and electronics within the machine. But essentially, the machine body has changed, so it's become essentially a living and breathing brain. It's connected, so it's adapted to our lifestyles now. So you can essentially sit on the tube and get your robot to clean up the apartment before you get home. Or if you're rushing out to work or elsewhere, you can do it for you. And you can keep a monitoring on that and get an idea of how it's learning and improving that efficiency all the way through. It's a very smart bit of kit. And as you can imagine, there's going to be a new evolution of this robot in the not too distant future. because we're always moving forward. We're very restless in terms of our achievement, and we want to improve the packaging as well. Looking in the mirror for us is really important. Constantly looking at how we're performing, both in terms of the technology through all our testing, listening intently to our users to understand what we can do better, what the machines can do better. But also, I think as well, we also learn from those experiences through the packaging. All our products are produced in Southeast Asia. So from a start point, we've got a global journey to undergo, which endures an awful lot of bruising and shaking and dropping and vibration, as you can imagine. And for something this packed full of technology, that's quite an ask. So we've managed to, for the first iteration of the robot, we managed to package it into a very compact, very simple courier box that itself just sort of talked for itself, really. It showed the clean and compact nature of the packaging and the product, but also had a huge technical challenge for it. We needed to get rid of all the bumps and vibrations, essentially, that would damage the delicate circuitry within the machine. We tried a number of things. We tried some thermoforming, we tried some air packaging, but eventually ended up with a medium density foam structure. You can see there, 2 pieces very deep, a structure in the lid as well. They contain another thermoform to protect the delicate eye on top. It was a lot of foam. As we know now, it's probably one of the most environmentally unfriendly materials we could have used. Something that we are not particularly proud of, and certainly at the time, it was very much felt as a compromise. But at the time, we hadn't got the engineering to work with something else as an alternative. So once the machine was out of there, it was free. But to get there was, in the first place, was the struggle. And I took this, I think, from a YouTube video. There's several unboxings of this machine around, and you can see some of the struggles that people have with it. But it just reinforces, I think, that experience, that unboxing experience, that is very important for products of significant purchase like this. But also, it talks a lot about the brand and the principles of the brand. So again, we were having these boxes shrink wrapped. You can see actually on here, I think, there's the job the shrink wrap is doing in terms of protecting from scuffs and bumps. So it's functional, but it's also very thick and awkward to get off the box in the first place. I think it gets worse. Yeah, it does get worse. We had to wrap up the power cords and the plugs with protective film, again, to avoid scratching. Not great, certainly not great to see any sort of blades or knives around packaging. So you can see already the challenges were stacking up here. My particular favourite that has been the bane for many years is the lamy bags that we have to use every now and again. This lamy bag is like an expanded foam, very thin layer that wraps essentially the entire robot. Does a great job of protecting it from dust, which is one of our worst enemies in terms of getting inside the robot, in particular the lens of the eye. You can imagine it's like getting a bit of dust on a satellite lens. It's catastrophic. So we had to eventually put the robot into a sealed bag. This lamy bag is, again, not recyclable. It's just a really, really bad news. But worse than that, I think, from my point of view, it tends to make everything look a bit like a snowman. It just doesn't look great. And what a beautiful product it is. It's such a shame to be wrapped in something like that. But for me, I think one of the key things was the big foam. I mean, it was very, very good at its performance. It really did deliver a huge amount of absorption in terms of energy, vibration. However, going to see these produced over in Malaysia was one of the sort of most shameful, I think, moments of my career so far. To see the waste generated by punching big, thick holes in these sheets, not really knowing where they went to. We were told they were going into furniture or other products, but you suspect that there's probably a bit of a grim story behind it, and something that we needed to act on. So we set about changing this. We were clearly looking to be a lot more sustainable, but also we needed to relaunch the robot in a year or so. So we had time to do something about it and really address these materials that were high performance, but certainly not at all good for the environment. And get rid of that bag. So I always find it very healthy just to not just focus on your own pioneering stuff, but us just stand back a bit, look at what everybody else is doing, just to kind of get a sense of the vision that you have for your packaging, but also understand really where others have tried things, perhaps achieved things, often struggled with things. And what we got from this exercise was that all our other kind of imitators and competitors were producing a lot of clutter. I mean, what you've got there is you can see a mixture of thermoforms, EPSs, pulp trays, a lot of materials there that are around avoiding abrasion, so lots of polybags, protective films. It's a real mess, very confusing in terms of disposal and recycling. Very expensive, no doubt, not just for the assembly of it, but for the individual components themselves. And just a real mixed message in terms of what the brand or what the machine is trying to show. So it really kind of reinforced our vision of producing and aiming for something that was about simplicity, beauty, and sustainability. So we set about going forward and giving the packaging to this new version of the robot something that was worthy of its simplicity and its beauty. I'm going to show a quick video now, just to give a bit of a glimpse of the machine in action. It also shows you a bit of a glimpse of the development journey that we went on for this. And you'll see elements of our testing, our simulation work we've done, a lot of the trials, and a bit of a taste of our world in which we work. And I'll take you through a bit of those technical stories afterwards. But yeah, enjoy the video.
明日から各家電量販店にて販売開始される最新のものがこちら。小型で軽量なデジタルモーター V2 によってを実現。さらに機体と同じ幅の大きなブラシバーを搭載。どんな材質の床でも一度ですっきりゴミを取り除いていきます。すごい。さらに360度を見渡せるカメラが最大1秒間に30枚の画像を撮影しながら部屋の全体像を認識。最も効率的な掃除経路を導き出します。従来のランダムに動くものと違い、ムラのない効率的な経路を自ら考え掃除するんですね。
There you go. That was a bit of a glimpse of essentially about 18 months' work, working closely with the team actually designing and producing all the robotics, technology of the robot itself, but also leveraging something that's really important for us. We have a global network of partners that we lean on every now and again, and that stems not just from Southeast Asia, but across the globe. And one of our partners, based over in the States, introduced us to a world of mechanical simulation. And so we looked to try and understand and almost reverse engineer a target for this particular machine. Our vision was to really protect the components and technology of the machine, but at the same time, show off all these beautiful surfaces you can see on screen there, with the clear polycarbonates and gorgeous blue painted colors that you can see. We wanted to see that as a first reveal, and you open the box. You've spent a lot of money on this. It's a great experience. It's very exciting. You want to get your hands on it quickly, get it going, get cleaning. And that was really it. We wanted to just sort of strip it back to pure simplicity. And in order to do that, we needed to sort of look carefully from within. And within is a very complex assembly. I've got the machine here. You can see it's pretty heavy. It's about 5K, I think it is. But essentially, it's got all the qualities of a Fabergé egg, but yeah, with a brain essentially. So you can clean your apartment, but look beautiful and be just as delicate. These are drop tested and tested for bumping into furniture, falling downstairs, that kind of thing. But when it comes to our own packaging testing, we have very robust targets to hit. And by removing all that foam that we saw earlier, was going to open up some huge challenges for us. So we needed to move it on a bit. Not just the beautiful surfaces that would obviously be very vulnerable to scuffing and scratching. We also had a lot of mechanical features underneath. Spring-loaded feet, these caterpillar tracks you can see. They had energy of themselves. We've got various cleaning brushes that can't be in contact for too long. And with the journey across the sea of about 5-6 weeks sometimes, all these considerations need to be built into something that we're going to be working with. So we took it straight back, and we started off by going back and looking at some of those kind of core targets to hit. And for us, the testing bed and testing methods that we have really give us that crucial start point where we want to understand how much energy, in this case, we wanted to absorb and remove from a box falling off a shelf or falling in your home onto a hard surface. So we built a surrogate model. We embedded accelerometers into that, and then run it through various transit testing, various profiles for a journey across China, journey across the US, through Korea, just to understand the kind of abuse and physical, mechanical challenges for the machine to undergo. But at the same time, be able to still deliver that very clean and crisp presentation of the robot when our consumer opens it for the first time. It led us to essentially a very simple thermoform shell, essentially creating a structure, an assembly that basically floated the machine in midair. So we had the main machine sat in a central tray with a tray on top, a tray underneath. So essentially you could bounce with left and right suspension all the way, every axis. But to find a thermoform material that could deliver those properties without the cracking and splitting, without the abrasion, without the various fallibilities that those thermoforms usually have, was a real challenge. So we worked our way through a whole number of samples and a couple of tool sets as well. But we got to a point where we were able to focus in on a chemical structure and material that we felt was perfect. Crucially, apart from absorbing those forces and energy, it enabled us to remove the protective films, the lamy bags, all those barriers to getting your hands on that machine on opening. But also, as you can see, it becomes suddenly a very powerful visual message when you open that box. It's something that we wanted to embrace and make the most of. So all this work that we've been doing, all the drop testing, all the simulation work, and the simulations you saw in the video, lent itself to an HDPE spec. We tried the various APEX PP in terms of thermoforming, but at some point, every one of them let us down at some instance. And in the end, we ended up with a quite high spec HDPE. Itself very versatile as a recycling material. We tried using a recycled content HDPE, but we ended up having to ditched that approach because a number of reasons, but primarily the mechanical performance wasn't there. The cosmetic appearance on the surface was quite pitted, a little bit like an orange. And that change in surface meant that where you have parts of the thermoform in contact with smooth surfaces of the product, it tends to become like an abrasive surface again. So that and the kind of surprise, I suppose, that nobody really wanted to sell us any recycled HDPE. We looked far and wide. And it just sort of uncovered the fact that I think recycling or producing recycled content material is a really expensive business. It's very technically challenging. It's a drain on a lot of cleaning processes as well to get to a point, because we wanted white for this one. To get that kind of purity was in the region of, I think, about 6 to 8 times more expensive than virgin. So with that in mind, we thought, okay, well, if we can't use recycled content, we're going to shout about the fact that this is a very versatile recyclable material. And so we incorporated the Mobius loop and across various different markets, and a very clear, bold symbol that could be interpreted and understood for that end of life moment. And we again used in the bottom trade, taking care of the charging plug and the dock that the robot goes onto. Those in turn were also embossed with that HDPE Mobius loop. So yeah, we had a very, very clean, simple assembly in the end. We also managed to get rid of all the glue and tape that was incorporated in the initial box. So within the same footprint and within the same budget, we managed to produce something that was very credible and a much more sustainable solution for us. But I think you'll agree that in terms of presenting the machine, there's a huge justice to all that engineering work. And we also addressed the shrink wrap that wrapped up the machine that you saw at the start. We replaced that with transit sleeve that was, again, just as good in terms of performance, in terms of absorbing bruises and scuffing, but obviously much more recyclable and ripped off to be a very flat piece. So we kind of addressed every single aspect that we could. But at the same time, just keeping an eye on what everyone else was doing. The latest releases that were coming out at the time were using a lot of molded fiber. So we went back and we just checked that molded fiber wasn't the option for us. And so we ran it through, same processes, same testing, same block tests. And molded fiber itself would then consistently split and tear. And that tearing released fibers from the structure. And those fibers, essentially that dust particle, for us is catastrophic. And so just enabled us to make very clear decisions that using molded fiber is great, but the presentation and mechanical performance is going to be a bit suspect, plus the dust. And when the dust is there, you then have to reintroduce a bag into that assembly. So you can see scoring it and giving it a metric as to what's the most important thing is a very, very critical thing for us. But where we do use that polymer for HDPE, we make sure that we talk about it and encourage that recycling process after. So here's our before and after. Quite a difference, same footprint, same budget, much better performance. And when you strip it down and tear it down, you can see that essentially it's just two materials. We've got that two parts really, with the box, which is a top coat of it's OPP laminate on there, but it has a huge benefit, and there's no glue anymore, there's no tape, there's no foam, and the 3 thermoform trays that sit alongside. So at first we launched this over in Japan, and after a while we recognised that actually it was being very well received, and it gained us a nomination for the Packaging Awards in the UK, which we were highly commended. And then again in the Luxury Packaging Awards for technical achievement and innovation, respectively. I think in the UK Packaging Awards, actually, we were beaten. We came in second place behind a wrap for a pack of sausages. So it kind of very different product, very contrasting market and achievement, but again, both delivering some very clear, sustainable goals there. It is great to get that recognition and recognition for, I think, the partnerships and the collaboration that we've done over the years, and we continue to do for our team in SEA and our team in the UK as well. But being Dyson, of course, we don't rest on awards. We kind of keep going, and it's never really good enough to sort of sit back. So we're always looking around, and this was another instance where we identified, or it was identified for us, there was actually far too many polybags in one of our floor care products. This was probably 4 or 5 years ago, but this kind of spurred on a huge move to remove as much polybags or unnecessary packaging, unnecessary weight and materials and inserts as we can. This chap, I think, made a letter to a newspaper, a local newspaper in the UK, and that really was a sort of a spark that kicked off a huge amount of work and a real change of mindset, I think, from designing boxes that could survive a journey across the world, built like an armored vehicle, to something a lot more refined. I think that's where I think we're looking now to be removing material as much as possible, lightweighting things and redesigning things to make sure that we are being lean engineering and using the right materials all the way through. We've done a lot of pioneering work in molded fiber, both in our lighting categories and our business categories where we're doing hand dryers, bigger products. We've also been, as you're probably aware, some of our hairdryer products, and that category itself uses a much more refined pulp, again, 100% recycled. We've got a number of different blends in there as well, using natural materials, natural fibers to achieve those qualities. And achieving those qualities means that we can remove those traditional protective barriers and films, bags, stickers, that kind of thing, that free us up from single-use plastics and free us up from that clutter that everybody else suffers from. This is probably one of the key products that started this all. This light was actually designed by Jake Dyson. When it was originally launched, it was essentially a case the size of like a big violin case, 2 big blocks of EPS foam, in which a very delicate light was housed. And this was one of the first things I got hold of a while ago, and we reimagined it, redesigned it. And essentially, the lighting now uses a very well executed dry press pulp, again produced in Asia, but engineered in the UK. And you can see how not only the size of the box is much more sleek, but the presentation of the product is much more elegant. It really helps us build these products simply, clearly, and ultimately protects them. But at the end of the day, these are big cumbersome boxes, and they're not really the kind of boxes you want to keep around the house. So they break down very simply back into recycling streams that throughout our markets are very common. So that was our robot story. We try and do everything with these values in mind. There will, of course, be others as we apply these values all across our products. You'll see more things coming soon. And again, the packaging will itself be changing and evolving, become more sustainable, smarter and leaner across our products and packaging and everything we do. Thank you very much. Hope you found that interesting.